on the bottom of your screen. Bottom of your screen. I will wait until the end of the presentation to ask our speaker questions, and we will try to answer as many as we can. It's my pleasure to introduce Professor Tom Fitz. Professor Fitz has been studying the geology of the Lake Superior region for decades and has been teaching geology at Northland College in Ashland, Wisconsin since 1999. His expertise is in geologic history and the relationship between people and the earth. He earned his BS, MS, and PhD degrees in geology and has earned many teaching awards during his career. With that, I will turn it over to Professor Fitz.
So just hit that share screen button again at the bottom,
okay.
Tom.
Yep. Okay, wait a second. Okay. Hang on.
You're good.
Share screen. Okay.
There it comes.
Yep. Okay. Are we good?
Looking good, sounding good. Thank you, Tom.
Hey, good. Okay, thank you very much. And thank you for participating in this great conference here about the lakes of Northwest Wisconsin. It's a great opportunity to share and to celebrate our appreciation for the numerous lakes in this region. And it really is the lakes that are one of the most important factors that make this such a special place to live and to recreate. Wisconsin has a lot of lakes. There are about 15,000 lakes in the state, about 6,000 of which are large enough to be named. And that makes up a total of 1.2 million acres. So it really is very rich in lakes. This talk is going to be about the history of the lakes, why we have so many lakes, and what are the variables that affect the different types of lakes, because there really is a great diversity of lakes here. So what we'll do is first I'm going to talk about the setting of why the lakes are here, and then their setting, and then we'll do a little bit of a tour around Northwest Wisconsin, and we'll take a look at some special lakes. Okay, it basically takes two things to have a lake. You need to have a basin that will hold water, all right, to have a lake in it, and there has to be enough water. So you need both of those things. You need both a landscape that has basins in it, and you need to have a wet enough climate. And like so many things in the natural world, what is taking place around us really has a lot to do with, or it's very much controlled by, what was the geologic history of that region and what is the current climate. And the geologic history really has to do with what happened there and what the materials are. And there are only a few geologic settings where lakes can occur. And it's interesting because here in Northwest Wisconsin, we think about how common lakes are, but globally, they're not all that common because it takes a special set of circumstances to make a lake. And some of the geologic circumstances are here in the upper left. That is Crater Lake in Oregon. So volcanic craters, that's a way that a basin can be created by volcanic eruptions, creating a crater. And those are common in volcanic regions. And although Northwest Wisconsin had a lot of volcanic activity a billion years ago, it was so long ago that it's much older. Those rocks are much older than the landscape. The landscape around us is really very young, and there are no longer any volcanic craters that hold lakes. On the upper right, what we have, this is another situation where basins are created, and that is in sinkholes, where the top of a cave in a limestone region collapses in and makes a sinkhole. And that's called karst topography. There is some karst topography in Wisconsin, but it's mostly in the southwestern part of the state, and we don't have limestone up here in the northwest, so that is not, we don't have karst lakes, sinkhole lakes. Another one, this one's kind of rare in the lower left, what we have are impact craters, meteor impact craters. That's a beautiful one up in Siberia, okay, that is now has a lake in it, a fairly recent meteorite impact. And there have, of course, been meteorite impacts everywhere, but they're not that common, and we don't have any meteorite impact lakes around here. And then in the lower right, we have the ones that we're going to be talking about today, and that is in glacial landscape, where the landscape is a young landscape created by recent glaciation, and there are lots of basins that can hold water, okay? And there are plenty of places on Earth where there may be basins, but there isn't enough water. So we need both a basin and we need a lot of water to fill up the landscape. This is in Southern California, where there is an interesting topography, but there isn't enough water to fill up the landscape. You know, and the groundwater there is about 800 feet down. So there's no surface water whatsoever. When it rains in a landscape like that, the few times that it does rain, the water soaks right in or quickly evaporates, and the groundwater is at great depth. So there is no surface water in a lot of areas on Earth. But in Wisconsin, we have the right combination of a recent glaciation and a wet enough climate to fill up the landscape and have a high water table, and it takes both of those things. Okay, this is a typical view of Northwest Wisconsin. Actually, this was actually in Vilas County in Northeast Wisconsin. I took that picture while flying out of Ironwood, but that's a pretty typical scene, okay, with lots of basins and a high water table that has filled up the landscape. And there's a great diversity of types of lakes and different ecosystems. So first, what we want to do is we want to understand, why are they here? Why are they on this landscape? Okay, and that takes us back to glaciation. Okay, the last glaciation to enter Wisconsin, the last big ice sheet, the Laurentide Ice Sheet, entered Wisconsin about 30,000 years ago and reached its maximum, extending down into the southern part of the state and even further south. About 23,000 years ago was the last glacial maximum. And then it gradually melted back. It advanced a few times and melted back, and then eventually left Wisconsin, left this region about 11,700 years ago. And when the ice melted, it revealed a new landscape, right? So it's a fairly new, geologically speaking, it's a fairly new landscape. Okay, so glaciers are big and heavy, especially these great big continental ice sheets. And so when they advance, they incorporate any loose material into the bottom of the glacier, and it scours down to bedrock, right? And this is a beautiful bedrock, scoured bedrock surface that we see here. And what it does is it sculpts the bedrock. It doesn't gouge too deeply, but it does sculpt it down and make basins and ridges that can hold water. Okay, so that's one of the origins. Mostly, these are erosional landforms. And in the northeast part of the state, we do have some lakes that occupy basins, bedrock basins that are erosional, but mostly what we have is depositional landforms. So when a glacier is melting back, it drops all of the sediment that it has been carrying, and it makes depositional landforms. And this map from the Wisconsin Geological Survey shows these lines, okay, I'll use the pointer here, shows the lines, okay, and each one of these lines represents the edge of the ice sheet at different times as it was melting back. And what it does is it leaves a little ridge called a moraine at each time it pauses as it's melting back. So you can see the succession of moraines that were created as the glacier was leaving. And as I said, leaving finally about 11,700 years ago. Okay, when a glacier melts, it is messy. There's a lot of water, there's a lot of sediment, and a lot of different depositional environments, what we call. Okay, so the landscape is being created from the sediment that is being deposited. I want to point out a couple of things here. Okay, an esker is a place where there was a river running out of the glacier, and it created a ridge underneath the ice. And when the ice melted away, we have this big long ridge that was a lake, that was a riverbed. Okay, this is a moraine right here. And you can see on the moraine, you can see these holes that are called Kettle Lakes. And we're going to talk about those in more detail, okay, because we have a lot of Kettle Lakes here in Northwest Wisconsin. And then this lake and this lake right here, you can see are held back by the moraine, which is actually acting as a dam. Okay, so a lot of different environments, and many of which can have basins that will hold water. Okay, and as I mentioned, it is the glaciation 11,700 years ago. That's a really recent geologic event. I know that's a long time in human years, but that's fairly recent. And so what happens is there just hasn't been time in that 11,700 years for the rivers to become an integrated drainage pattern that is very effective at draining the land. And this is what we call a deranged drainage pattern. Okay, it is a young landscape without a well-integrated drainage system, and we call that deranged. It's a young deranged drainage system. So here we go. This is kind of a typical scene. Okay, there are a lot of lakes, there are a lot of wetlands, there are some rivers, okay, meandering rivers, and the rivers are carving down into it. And very gradually over time, over thousands and thousands of years, the rivers will continue to cut down into this glacial landscape and become a better integrated drainage system. And it will gradually the landscape will be transformed. But what we have now is a lot of lakes, a lot of wetlands, and this deranged drainage pattern. Okay, let's go back to the Kettle Lake. All right, when a glacier is starting to melt, all right, often what will happen is it will stop. It will stop on the landscape, and it's no longer moving. And now it's just basically dead ice. It's stagnant ice. And right near the end of the glacier is melting, and there's a lot of sediment and water being flushed out of the end of the glacier. And there are blocks. There are often blocks of ice, dead ice, that are sitting there on the landscape, and they get buried in the glacial outwash. And then eventually, those ice blocks will melt, and they will leave a hole in the ground, okay, a basin. And we have a lot of Kettle Lakes in northern Wisconsin, because when the ice was melting, there was a time period when it basically stopped and it was just stagnant ice melting on the landscape, okay? And this is a pretty typical scene, all right? And it is, think of this, envision this 11,000 years ago, when each one of these was a big block of ice just sitting there. There's a glacial margin not too far to the north. It's melting and shedding lots of sediment into this region, and the ice blocks are being buried and then eventually melting out and leaving these basins that later are going to hold water and be the beautiful Kettle Lakes that we have. That's impressive, isn't it? I mean, that landscape must be about 20%, 15-20% lake right there. Okay, and here we have, this is in the area of Ellison Lake, just east of Soland Springs. And this is a typical scene what we see here is lots of Kettle Lakes. You know, they're sort of roundish like Sand Lake or sort of weird oblong forms. Each one of these was an ice block. And then in between them, we see all these hills, okay? And these hills are areas where the sediment was being deposited and like piling up and burying the ice blocks. Okay, beautiful Kettle Lakes. And you notice that there really are no rivers there. Okay, we'll be talking about how the drainage occurs in these Kettle Lakes. Okay, so Kettle Lakes are very common. I want to point this one out as well. Right, I mentioned that when the ice is melting, there are rivers flowing out from underneath the glacier, and it can be sort of an interesting, messy situation. In some places, what's happening is the river is actually eroding down into its base, and then at other times and other places, it might be piling up sediment and making an esker. Or if in the case of when it's eroding, it can make what's called a tunnel valley, right? And a tunnel valley can then end up being a long, narrow lake years later. Okay, so let's take a look at a couple of lakes here, all right? Let's go over to Straight Lake in the area of Straight Lake State Park in Polk County, all right, near Straight Lake. Here is Straight Lake right here. Actually, Straight Lake State Park is up here to the northwest. This is near the town of Locke, right? And this is Straight Lake right there. And this is a long, skinny valley right here that is occupied by Straight Lake and Long Lake up that way, and then the Straight River. And that is a tunnel valley, all right? So the glacier was up here. The water was flowing out of the glacier, coming down here to the northeast, probably 13,000 years ago. All right, and then it's interesting because this is definitely a tunnel valley, okay, but this ridge that comes down the middle of it, which is a peninsula here and separates two lakes, all right, is an esker. So this was a big stagnant ice block that had water flowing out underneath it, first to create a tunnel valley, and then there was a deposit by the river in the middle of that valley to create an esker. So it's an esker within a tunnel valley, and it now has lakes all around it. So that's a pretty cool geologic history right there. Okay, there are other lakes that are not closely associated with glaciation. There are fewer of these in Wisconsin, okay, but these are impoundment lakes where a river has been dammed up and there's an impoundment lake behind it. These are not as common in Wisconsin. Most of our lakes are somehow associated with glacial landforms such as kettles and moraines and tunnel valleys, right? But in many parts of the United States, impoundment lakes are the most common ones, okay? And mostly they are created by humans, but humans aren't the only things that make impoundments, and beavers have been doing this for millennia, all right, and making small ponds by damming up creeks. Okay, yeah, so lots of different environments are created during a melting glacier, and so lots of different characteristics, right? So now what we need to think about is why are the lakes so different, okay? So we've got the basins created by the glaciation. We have this landscape that has lots of valleys in it, tunnel valleys and kettles, but then we also need to have the precipitation, all right? So the water has to be coming from the sky. And it's important to realize that all of the water in the lakes here, it came down fairly recently as precipitation. So rain and snow is the only way that the water gets into the land, all right? And here we have the inches of rain per year in inches of rain and snow equivalent, okay? And for Wisconsin, and what we have is about 32 inches of rain per year in the Northwest region, right? And 32 inches of rain per year is enough to fill up the landscape. It's enough to have a fairly high water table, and it's enough to have a robust forest ecosystem as well. Below about 15 inches of rain per year, then it's going to be a very different type of drainage system, and less than 10 inches of rain per year, there probably is no surface water whatsoever because it's probably all infiltrates and evaporates. So it takes that 32 inches of rain per year is also very important. And I want to compare these two. Okay, what we have here is the average annual precipitation for the United States on the left, and you can see the area of glaciation. So the northeastern part of the United States was glaciated, right? And it's these two things that come together to give us a lot of lakes. And if you think about where are lakes in the United States, they primarily occur in this area that has been glaciated and has a wet enough climate to have a landscape that is full of water. So it has both the basins and the water, right? Okay, so now what we know, that's the origin of the lakes. Now what we want to do is we want to think about the setting of the lakes and why we have so many different kinds of settings and different ecosystems, because we have a lot of different aquatic ecosystems within the lakes of Northwest Wisconsin. And a lot of it has to do with what we call the budget, the water budget of the lake. How does the water get into and how does the water get out of the lake? Okay, right. Keep in mind that it's all coming down as precipitation. Okay, now although all of these kettles and these tunnel valleys had glaciers in them long ago, right, the hydrologic cycle, the water cycle keeps going. And any water that was here that was original lake, that was original ice water that was in the lake at the time of glaciation, that has long since been flushed out. Okay, so all of the water here, none of it remains from the glaciation. It's all water that has fallen from the sky fairly recently and is now flowing off the land as it is draining as surface water and groundwater. Okay, so it all comes in as precipitation and it can fall directly into the lake. Okay, it can hit the surface of the ground and it can flow off as surface water. And then it can also flow as groundwater. And there are lots of different combinations of ways that water can get into or out of a lake. And that has a strong influence on the characteristics of that lake. This lake right here that we see is just being fed by precipitation and by runoff and by groundwater. Okay, this is called a seepage lake. And Mary Jo actually mentioned this at the beginning of the conference, and she was introducing things. All right, so this is a seepage lake, and the water is flowing out by groundwater flow. Okay, flows in by groundwater flow, out by groundwater flow. And it isn't connected with rivers. All right. So when you first look at that landscape, you might think, how does the water get into and out of this lake? All right. But it does. It can flow as groundwater because these glacial sediments, it's a lot of sand, right? And the sand is really pretty permeable to the water. The water can go right through the sand and it can move into the next lake basin. Okay. So this lake is getting water from the sky, also from surface runoff, but also from groundwater, and then it's leaving via a river, okay? So this one is going to be called a drainage lake. And then this one down here, right, this one has water coming in as a river and leaving as a river, so that is a drainage lake as well. Okay, so there are lots of different combinations. Water can be coming in just by groundwater or by a groundwater and river. So lots of different combinations of ways that water gets into and out of the lake. And it's important to keep these in mind because the proportion of water that comes from these different sources can make a difference in what the lake habitat is like. For example, how cold the water is. The groundwater is cold. The groundwater is about the same temperature as the average annual air temperature, about 42 degrees, right? Whereas lake water, if it's in a shallow lake, can become warmed up a lot, right? So the proportion of water that is surface water and groundwater are important. Okay, going back to this area, Ellison Lake near Soland Springs, and you can see there aren't rivers here, right? So all of these are seepage lakes, and the water table, it's a fairly shallow water table, right? And the water is moving. There's some kind of a regional gradient here, and the water is flowing slowly, from one lake through the sand into the next lake, through the sand. It's basically moving as groundwater underneath all these things. And the Kettle Lakes intercept that groundwater. So the surface water and the groundwater are interconnected. Okay, so that's something to keep in mind. Even if there isn't a river, the water in the lake is changing, right? It's all moving. Maybe it's moving slowly, but it is all moving. Another important thing to keep in mind about why we have different types of lakes and why we have different characteristics in the lakes is the depth of the water. The lake depth is a really important thing, characteristic, right? And this is a map of, this is Lake Owen, the north end of Lake Owen in Bayfield County. And a map that shows the depth is actually called a bathymetric chart. So you can look up a bathymetric chart for any of the named lakes in Wisconsin. You go to the Wisconsin DNR webpage, and you can get a bathymetric chart for any lake. So if you want to fish, you want to see how deep the water is, right, you can go to that webpage. One of the reasons that the depth of the water is so important is because of the connection to the surface, to the atmosphere, and to sunshine. And a shallow lake, right, when in the summertime, this time of year, a lot of sunshine, a lot of warmth, and the surface waters can get warmed up a lot. Whereas waters down deep, okay, they will remain down there and they won't be warmed up. So the depth of the lake, in a deep lake, there can be a lot more cold water down there versus a shallow lake, the whole thing can get warmed up. So the temperature gradient in the lake and the overall temperature of the lake is different depending upon how deep it is. And as we heard in Kathy Peckman's talk, the temperature of the lake is one of the master controls, right? So the depth of the lake is also then one of the master controls because the depth of the lake has a large influence on how warm it will be. And then we also need to think about the geologic materials that the water is in contact with, okay? Because there can be minerals that dissolve out of the sediments or out of the rock and can be nutrients, and they can affect the water quality, okay? And they can affect what grows in the lake water as well. Okay, and here in Northwest Wisconsin, mostly the materials are basically the rocks, the granite of the Canadian Shield, and these rocks are quartz, and a lot of quartz, and not a lot of soluble minerals. It's a very different material here than, for example, in some parts in the southern part of Wisconsin, where there's limestone, which is very soluble and will add a lot of dissolved minerals to the water, right? So we don't have a lot of dissolved minerals in the water here in comparison to other places, right? What we have is a lot of sand, a lot of gravel, and that doesn't add a lot of dissolved minerals, but it is very permeable. The water can go through it pretty well, and that's why we can have seepage lakes. That's what it's like in most parts, but then up in the Lake Superior lowlands, there is a lot of clay, a lot of Lake Superior red clay, right? And that's because of the glacial history in the north. Actually, there was a big lake at the time of melting glaciers. And a lot of mud was deposited on the bottom of that lake. And so there's a thick clay deposit in the Lake Superior lowlands. And that affects the way the groundwater flows because clay is pretty much impermeable. Water doesn't go through clay. Okay, so in this area where there's a lot of red clay, the lakes are drainage lakes. They're not seepage lakes. And that affects the flow of the water. Okay, the clay is pretty insoluble as well, so it does not add many dissolved minerals either. Another factor that influences the setting in a lake is its position in the watershed, right? So we have lakes that are high in the watershed versus lakes that are lower down in the watershed. This can make a difference depending upon how the water flows through this watershed. It can be, in many places, especially in drainage lakes, where the water lower down in the drainage basin, in the watershed, will have been at Earth's surface for longer. It will be warmer. It often has more tannic acid in it from having been in contact with decomposing organic material, and it can be very different water quality. So there are a lot of variables here, but position in the landscape is one of them, and how the water flows from one lake to the next. Okay. Yeah, this is one of the reasons that that's important, is that in areas where there is a lot of clay, right, there can be slumping. So this slope right here was slumping for a long time, and this is Deer Creek that was flowing down into White River and eventually into Lake Superior. And the slumping of the clay down into the creek was affecting the water quality, and it was making it very turbid. All right, and we still see this a lot in some places in the Lake Superior clay plain. And this is Chequamegon Bay on Lake Superior. And this is a very typical scene after a heavy rain, where the clay of the clay banks has washed down into the rivers, and the rivers have flowed into Lake Superior and put a lot of suspended silt and clay into the water. And the water is what we call, it has high turbidity, right? And it's not very clear, and that can have an influence on the water quality. It can have an influence on the bottom, as that clay is eventually going to settle out onto the bottom. Okay, that was from a big storm. We've had, as Kathy mentioned, we've had a lot of big storms in the last few summers, and that was one of them, one of the big ones in 2016 or 17 that dumped a lot of clay into the bay. Okay, and let me go back to that. And you think about the sun shining on that, and the water is dark, and the sunshine is going to heat up the darker water because it has that suspended sediment in it. So this is going to affect the temperature of the water. And of course, as we said, the temperature of the water is one of the master controls. So if there's high turbidity, if there's a lot of suspended material in there, if it's not as clear, then it's going to warm up faster, and that affects the what can live in the water. Okay, and here you have, this is the temperature with the depth going down and the temperature across this way, and you can see there is the thermocline, is where it goes from the warm water at the surface down into the cold water at depths. All right, so we can have a lot of difference in temperature from one time to another. And what happens is that when it gets warm on the top, all right, the water is warmer and it floats. It floats on the rest of the lake. And so the lake becomes stratified, okay? And so the bottom water down here in the summertime, the bottom water is not in contact with the atmosphere. It stays cold. And the fact that it's not in contact with the atmosphere is an important thing, because if it's a shallow lake, all right, if it's not that deep, but there's cold water down there, then what can happen is the oxygen can get used up, right? And so it can be decreasing oxygen levels in a lake that is stratified for a long period of time. And then what happens in the fall, right, is we get cold again, and the surface water will cool off, and that cold water will sink, and there'll be what we call an overturn of the lake. And the overturning of the lakes, when it goes from stratified to overturning and it's no longer stratified, that's a very important process in the fall, and then again in the spring when the ice melts, okay, because that will mix the lake and it will bring oxygen back down into the bottom waters. Okay, so the movement of the water in the lake is very important through the year as well. Okay, so here we have it. We have a lot of different variables, right? We've got the amount of water coming in from groundwater, from surface water, and we've got different connections to the lakes around them. So a lot of different variables here, right? And so let's take a look at the different types of lakes with different types of variables. And the depth and the clarity of the water is one of the most important things, as we mentioned, right? And if we have really deep, clear, cold water lakes, all right, that's going to affect the habitat a great deal. This is actually Lake Superior. You can see how clear the water is there. And this is what we call an oligotrophic lake, all right? An oligotrophic lake has clear water, it's deep, it's cold. There aren't a lot of nutrients that support plant life and thus not a lot of animal life in here either. So these are cold, clear, deep water lakes called oligotrophic, all right? And of course, the habitat is one that is going to support trout, right? That like it cold and clear. Okay, if the lake is shallower, okay, and it is warmer because it warms up in the summertime, and there is plant life, there's some nutrients coming into this, then there's going to be more life in the lake. There's going to be some decomposition of organic material, which is going to create some tannic acids in the water that kind of makes it brown. I'm sure you've seen a lot of the sort of light brown water, sort of root beer brown, okay, in a lot of lakes. These lakes are sort of in the middle. They're not oligotrophic. They have a medium amount of light, a little bit of brown tint in the water like that. These are called mesotrophic lakes, all right? And we have a lot of mesotrophic lakes. They're warmer and they tend to support bass, okay, rather than trout. And then there's where there is a very shallow water, it gets warm and it's very conducive to plant life, and especially if there are nutrients, a lot of nutrients coming in, then it can be shallow, murky water. And these are what we call oligotrophic lakes, not oligotrophic, eutrophic lakes, excuse me, eutrophic, all right? And the process of eutrophication is when the lake is actually becoming more and more filled with plant life, right? And eutrophication, that process, can be accelerated greatly by human activities, especially fertilizer use, okay? This is from the US Geological Survey. This was in Florida, right? And a very eutrophic pond here. They're probably putting a lot of fertilizer on the grass there and it runs off. And there's so much algae growing in there that it really has become stagnant water, and a lot of that algae is dying, going to the bottom and using up the oxygen on the bottom, and it's really pretty stagnant conditions in there. Okay, so eutrophication of lakes is a big deal, especially because humans can do some things that, with fertilizer especially, that can accelerate this process, right? And the change in the lake can be dramatic. Okay, but it doesn't have to be human induced. This process of natural eutrophication takes place slowly through very long periods of time, naturally in some of the shallow lakes around here. And that's why we have bogs. Okay, this is actually Kettle Lake bog in Ashland County. And it's a shallow kettle, all right, that holds water. And it's been warm enough for long enough that there's been a lot of plant growth, and the plant growth has been building up on the bottom of the lake and creating a bog. And that is actually a beautiful floating bog map there. Okay, this is not because this is natural eutrophication. It's not the eutrophication that comes from fertilizer. It's a natural, very slow process in shallow Kettle Lakes that we have a lot of here in Northwest Wisconsin. Okay, so there it is. We have all the right conditions for lakes. We've had this glacial landscape that has these basins in it. We have enough water filling these up. We have a shallow water table, and we have a diversity of sizes and different depths and interconnections of lakes. Okay, so why don't we do a little tour now? We're going to tour around Northwest Wisconsin, take a look at some beautiful lakes, some different situations, show you some of my favorite lakes as well. Okay. Actually, Before we go and dive into lakes, let's take a look at the Northwest Sands, okay? So we're actually going to go into the middle of the Bayfield Peninsula for a moment, just for contrast, okay? In the middle of the Bayfield Peninsula, there where the red star is, right, all the way down towards Barnes in this area, okay, is sand country. And when the glaciers melted from this region, there was a glacial lobe right here, and there was a glacial lobe right here. And basically, this area was just receiving a huge amount of sand being washed out of the glaciers to create the Northwest Sands. There's just a lot of sand here. It's just basically this part of Wisconsin is just a great big pile of sand. I mean, hundreds of feet deep, you know? I mean, several hundred feet, up to 500 or 600 feet of sand piled up here, and it's high. It's a very high part of the state, and since the sand is so permeable, what we see is we see dry kettles. All right. So this is an interesting thing. What we've been saying is you need to have two different things to have a lake, right? You have to have the basins, and you have to have enough water and a high enough water table. So this is actually in the middle of the, this is on the edge of the Chequamegon National Forest, and in the middle of the Bayfield Peninsula. And these holes right here, this is a hole, this is a kettle that is 200 feet deep, and there's no water in the bottom of it. Okay, so this is a great example of what we've been saying. Okay, you have to have the right combination of things. All right, you have to have the kettles, and you have to have enough rain, and it's got to be a high water table. So the reason there aren't lakes in this is just because it's so high and so sandy, and the water just goes right through it. And all of the drainage here is by groundwater, and the water just goes through that. It goes way down, you know, hundreds of feet down to the groundwater, and that's how it drains away, right? So we need this, again, the special set of circumstances. This was in the fall of 2019, before the pandemic hit, and the Wisconsin Geological Survey did some scientific drilling, drilled 3 or 4 holes up there in the Northwest Sands because they wanted to understand the groundwater flow in this region. And all of the holes that they drilled went 200 to 300 feet before they got to the water table. There was the water table down there, but there's just such a big tall pile of sand that basically there is no surface water. Okay, and while we're up here in the northwest part of the state, we might as well take a look at Lake Superior too. Okay, big beautiful Lake Superior, which is also owes its origin to the wet climate and the current wet climate and the glaciation, because basically the glaciation carved out the soft sandstones of the Lake Superior Basin and made this deep, deep sandstone bedrock basin that is now filled with water because of the wet climate. Okay, and the thing about Lake Superior is that like a lot of lakes and all the Great Lakes, the water level has been very high for about the last 5 years, which is interesting because about 10, 15 years ago, the water level was near record low, but it reached its peak about this time last year. It was near record historically high levels. And because of that, there was a lot of erosion, a lot of coastal erosion, a lot of property damage. Okay, I got this last week. This is from the NOAA webpage. And this light blue line is the average, is the high, the record highs. This is the median, the green line, and this is the record lows for each month. And this was last year. You can see that much of last summer, it was at or near record highs. And this is the line for this year. It's come down about 6 inches. Okay, so we have less shoreline erosion taking place. That's a good thing. There are a lot of property owners who are losing a lot of land and a lot of houses. Okay, if we're going to talk about water levels, we need to go down here to Pigeon Lake in southern Bayfield County. Okay, there's Pigeon Lake. It is just west of Drummond. Okay, and this was Wisconsin, from a news story in Wisconsin Public Radio in 2017, is when it was 2016, the water level started to come up in Pigeon Lake. And this is a seepage lake, right? And so the water level is just coming up. So it has to do somehow with the water budget, And it isn't been, although we've had some heavy rains, it hasn't been above average yearly precipitation. So what's going on here is not really clear, right? I took this picture last week of Pigeon Lake, and here's County Highway N. They've had to raise the road because the water level is coming up. It's not clear why this is happening. It may have to do something with the flow of groundwater out of the lake. Maybe somehow the aquifer is being compacted and affecting the groundwater flow out of the lake. Okay, which is what happened in Shell Lake. Okay, so we're going to go down to Shell Lake next. And the same thing happened at Shell Lake. Shell Lake, maybe 15 years ago, started coming up, and it too flooded a lot of property. A lot of people's houses and cabins were greatly affected, submerged by this. And again, this is a seepage lake, so it's fed by groundwater, and the water flows out as groundwater, right? It's not clear why this happened, but it could have been that some of the roads around this actually compacted soft sediment material. Maybe there was extra peat in there. Peat in the sediment makes it very compactable. So perhaps that's what happened. Perhaps the roads compacted the peat and caused there to be settling. Okay. We'll just do a few more lakes. Okay. Why don't we go to one of my favorite lakes here in southern Bayfield County is Lake Owen. Okay, and Lake Owen, you see how long and narrow it is? What do you think that is? It's long and narrow, and it's got some big peninsulas and skinny little islands like that. Yes, it is much like Straight Lake in that this is a tunnel valley, all right? And within the tunnel valley are eskers, all right? And these long, skinny islands like this, these are eskers. What a cool thing to have, the legacy of glaciation here on our landscape today. Okay, we'll do just one more. Okay, we'll go over to the St. Croix Flowage. This is a fascinating situation over near Gordon. Okay, and it is the St. Croix River, and it's dammed up here at the Gordon Dam. Okay, so it is a flowage, so it is partially an impoundment, but it is naturally a lake as well. And the interesting thing about this is that the St. Croix Flowage has a St. Croix River flowing out that way, and another river turns into the Brule River, goes out that way and into Lake Superior. Okay, so this is not common for a lake to have two outlets going in different directions, right? So this is really kind of a special place on the landscape. And it's not just on a drainage divide, it's on the Great Divide. So the water flowing out in the St. Croix is going eventually into the Mississippi and down into the Gulf of Mexico, whereas the water going out this way is going down into Lake Superior and eventually out into the North Atlantic. So that's a cool place on the landscape. Water going in both directions. Okay, so there we have it. Okay, we have lots of different settings of lakes, almost all of which have to do with the legacy of glaciation and this young glacial landscape that we have around us, and the current climate that has enough water to most of the basins are filled with water because the water table in most places is fairly shallow and can fill up these basins. All right, and so much of this goes back to the glacial legacy of the Laurentide Ice Sheet, the advance and the retreat of the great Laurentide Ice Sheet. And if we think about this, okay, this is what has happened is this is the result of climate change, right? I mean, the Laurentide Ice Sheet occurred, the advance of that occurred because the climate got colder, right? And then the Laurentide Ice Sheet left because the climate got warmer, right? And the change in temperature between the maximum glaciation and today actually wasn't that great because temperature has such a huge control on what's going on in the environment. So as Kathy told us, temperature is really one of the master controls, right? And we are now having climate change today. Climate change has accelerated because of human activities, and the lakes are changing in response to them. And as Kathy said, it's a complex set of variables, and we don't know exactly what's going to happen to the lakes, but we know the conditions are changing very fast in terms of the rate of change that has taken place in the past. And it's going to be a different place, right? I mean, the lakes are going to be changing, whether what they'll be getting warmer, whether they'll be rising or falling, probably has to do with local variables, as it does at Shell Lake and at Pigeon Lake. Okay, but we love our beautiful lakes here in Northwest Wisconsin, and we want to appreciate them and take care of them the best that we can. Thank you. And if there are questions, I'd be glad to take questions.
Hi, this is Sherry again. Yes, if you have any questions, please, the chat feature is down at the bottom of your screen in kind of the middle symbol there. We have a few minutes left if anybody had any questions. I think it's just fascinating how lucky we are to have all of the right conditions to have our lakes, and anytime you look at a map, you can just pick out what lakes and what kinds they are.
Okay, chat. Are there questions? Okay, here's the chat. Okay, good.
Yes, one of the questions we have is, what type of conditions are needed for fens to form?
Yeah, okay, so fens and bogs, they're slightly different because you need a shallow water table, and the flow of the water is what's important. In a bog, bogs are mostly fed from precipitation, all right? So they don't have as much nutrients coming out of the ground, right? Versus a fen, which is more groundwater fed, and there are some nutrients, some minerals, dissolved minerals coming in that way. Okay, so they're slightly different in terms of their groundwater flow, and then a little bit different in terms of their vegetation because of that.
Another question we have, Round Lake in Sawyer County, do you know what kind of lake that is and why it is so clear?
Sorry, I don't know the specifics of that, but the clarity of the lake certainly has to do with the setting of that particular lake, where it is in the watershed, its depth, the groundwater flow or surface water flow into it. So there are a number of variables that can affect that. And I'm sorry, I don't know about that one. I do know it's typical in areas where where it's mostly drainage lakes. All right, lakes higher in a watershed in a series of drainage lakes will be clearer because the water is mostly groundwater and precipitation, so it's colder rather than lakes that are lower down in a watershed that are warmer. Okay, so that can be some of it. Yeah, Lake Owen is also my favorite lake, and I'm headed there to camp today after the conference. Great. Yeah, Lake Owen is beautiful, beautiful clear water. It's probably pretty deep tunnel valley.
Do we have any other questions? We still have a few minutes. We could take a few more.
Okay. Thank you. Yeah, the flooding in Pigeon Lake is a great example of climate change. Yeah, it's interesting. It's a puzzling thing, and I was talking to some people in the Wisconsin Geological Survey about this just recently, and it's like it's just in that one area, right? I was like Pigeon Lake and Shell Lake, so it's just a few of these lakes that are coming up, unusually fast, but lakes around them are not. So it's an odd thing. It's hard to figure out what's exactly going on there, and we may not know, right? We may not know what's going on. We may never find out. But what happened at Shell Lake actually is eventually there was so much property damage that they put in a pumping system, and a very expensive pumping system in like a 3-mile pipeline, and they pumped water over the drainage divide to the north, I believe, into the next drainage basin to lower the lake level. And it worked. I mean, it's a great expense to protect people's property, but that's what has happened there. And over there at Pigeon Lake on Highway N, it's pretty sad scene to see these. There are several houses along there, some nice houses that are now under about 3 feet of water. And when I was there, I just drove Highway N last week, and you can tell the water level is still coming up because there are balsam trees in the forest that are recently dead and dying, which means that water is still coming up. And I don't know what the future holds there, but you know, Highway N is right there at lake level. Can you guys? Yes, okay, there's a question about guides for understanding the geology of this region. Yes, there are several. I'd highly recommend the Roadside Geology of Wisconsin by Bob Dott and John Addig. That's an excellent book. Also, Scott Spoolman has written 2 excellent books about the geology of Wisconsin. One is called Wisconsin Rocks, and the other one is a guide to the geology of Wisconsin state parks. Okay, so that's by Scott Spoolman. All excellent books. And then if you have questions, I always like to help people understand the geology of the region as well. Is there a set of lakes there's a set of lakes in Dane County similar to Pigeon? I think that the cause is due to rising water table in the area. Wonder if there are similar mechanisms for the northern set of lakes. Yeah, it certainly has to do with the rising water table since they're seepage lakes. But the question then becomes, why is the water table coming up just in certain basins, right? And that's the thing, it's just certain basins. And if it was, all the lakes in Northwest Wisconsin, then you can say, okay, well, the conditions are such now that the water, there's less evaporation or there's more water coming in, but it's not clear why some lakes are going up and some are not.
All right. Well, I want to thank you again. This was extremely interesting. And
Okay.
if you'd like, you can use the reaction buttons on the bottom of your screen for applaud or thumbs up to show your appreciation for our presenters. And I also want to thank all of our sponsors for their support of this conference. There will be a follow-up survey that Mary Jo spoke about earlier today. That'll be emailed to you, and we really appreciate your feedback. We do look at that feedback every year to help make the conference better the next year. So again, thank you. Your next session will begin at noon. And if you stay in this,